Okay, in this video, we are going to find equilibrium for a couple of systems. And so for a system, equilibrium means that it's not moving to the left or right, and the solution is not moving up and down at that point. So it's a stationary point. So we need to solve a system of equations that simultaneously we have that both x and y are not changing. So we need to find values of x and y so that the x dt is equal to 0, and at the same time we need dy dt to equal 0. So we need to solve a system of a system of equations that are just algebraic equations. So if we start with our first system, starting with the dy dt equation, we see that this is going to be 0 only if x is equal to -2. So any equilibrium that we have is going to need to have x is equal to -2. So that's one condition right there. But just setting x equal to -2 isn't going to guarantee that the other derivative is 0. So if x is equal to -2, then we can take a look at what implications that would have on the top equation. So we would have 2, and I'm going to plug in -2 for x, and then minus y plus 8, and we set that equal to 0, and now we need to solve for y. So that would give us minus y is -4, so y is equal to 4. So in this case, we found that the only way dy dt is 0 is if x is -2, and then dx dt is going to be 0 only if y is equal to 4. So in this case, we have just one equilibrium at -2, 4. And we'll see in some of these other examples, it's certainly possible to get a system that has more than one equilibrium. So let's take a look at the other equation. And so for this one, if we start on top, we can take dx dt, the equation for dx dt, and solve that by factoring out a y. And so from that, we can see that if y is equal to 0, that would make dx dt 0. Or if we have y is equal to x, this other factor would be 0. So let's take a look at each of these conditions. So for the first one, if y is equal to 0, we know the top equation is going to be 0. And the equation for dy dt, if I plug in 0 for y, is going to give me 0 minus 4 is equal to 0. So this equation clearly is a contradiction, so we have no solution. So that means that we hit a dead end with that. So y equals 0, that's great. It would make the top equation 0. But if we have that condition, there's no way that the second equation is equal to 0. So we can rule out this condition. So then let's take a look at the other equation, which is 2xy minus 4. So if we have y is equal to x, then that equation for dy dt becomes 2x squared, placing y with x, minus 4 is equal to 0. And so solving that quadratic equation, we get two solutions, that x is plus or minus the square root of 2. So if I first pick x is equal to square root of 2, this condition is going to tell me that y also must be square root of 2. And we have another solution, which is, well, if x is equal to minus square root of 2, then we set y equals minus square root of 2, and that would also give us an equilibrium. So in this example, we have two equilibrium. One at square root of 2, square root of 2, and one at minus square root of 2, minus square root of 2. And so one last thing to mention before we move on to some other examples is there are many ways that you could have chosen to solve these systems of equations. So for example, for this system over here, you could have solved for x, y, and then plug that into the second equation, and you would have gotten the same results.